Hello viewers, in today's class we are going to discuss one important problem from definite integral, right? So here we have to find the value of this integral from 0 to 2 pi, and we have mod of cos x over 2, right? So here we see that our integrand is a modulus function, right? So here we have to make use of the concept of absolute value function, right? So let us start. So here let us first call this integral as I, right? And here let us denote this function that is mod of cos x over 2 by f of x, right? Now let us first find out the critical points of cos x over 2 is equal to 0, right? So first we will solve this equation, that is whatever expression is given under this mod sign, we equate it to 0 and we'll find out the permissible values of x, right? So now cos x over 2 is equal to 0, so we can write cos x over 2 is equal to cos pi over 2, right? Because cos 90 is 0. Now here we'll make use of the concept of trigonometric equations, which says that if we have cos x is equal to cos y, then the solution or the general solution of this equation cos x is equal to cos y is given by x is equal to 2n pi plus minus y, right? So here we'll have y. So now here we have x over 2 for x, and for y we have pi over 2. So therefore we have x over 2 is equal to 2n pi plus minus pi over 2, and here n is an integer, right? So now multiplying throughout by 2, we have x is equal to 4n pi plus minus pi, right? So this is the general solution of this equation, cos x over 2 is equal to 0, where n is an integer. Now here if we substitute different values of n, we'll get different solutions, but here since the limits of integration are from 0 to 2 pi, hence we are interested only in those values of x which lies in this interval, right? That is from 0 to 2 pi. And if we have n is equal to 0, then we have x is equal to plus minus pi, and here we'll accept only plus pi, right? So now here we'll take only x is equal to plus pi and will not consider x is equal to minus pi, right? So pi, it lies between 0 and 2 pi, hence we'll now break this integral I as a sum of two integrals, right? First is from 0 to pi, and the other one is from pi to 2 pi, right? Okay, so now here we have mod of cos x over 2 dx, and here we have mod of cos x over 2 dx, right? So now we have two integrals. Now here we have to now decide the sign of this mod function, because we know the definition of mod function, which says that mod of x is equal to minus or plus x whenever x is greater than or equal to 0, and minus x whenever x is less than 0, right? So now here we have to decide this mod function in the intervals 0 to pi and pi to 2 pi, right? So now let us consider the first integral. See here x varies from 0 to pi, right? So here we have x greater than 0 but less than pi, right? And if we divide this inequality throughout by 2, we see that we have 0 over 2, that is 0, and here we have x over 2, and then we have pi over 2, right? So when x belongs to the interval 0 to pi, then x over 2 belongs to the interval 0 to pi by 2, right? So when x by 2 it lies between 0 and pi by 2, it means x by 2 belongs to the first quadrant, right? So it belongs to the first quadrant, and hence in the first quadrant the cosine function is positive, right? So cos x over 2 is a positive quantity in the first quadrant, because this angle, that is x over 2, it belongs to the first quadrant. So here we have plus cos x over 2 when x lies between x over 2 lies between 0 and pi by 2, right? Or in other words, we can also say that when x lies between 0 and pi. So mod of cos x over 2 is positive cos x over 2 when x belongs to 0 to pi. In that case, x over 2 belongs to 0 to pi by 2, right? And let us consider the second integral. So here x varies from pi to 2 pi. It means x lies between pi and 2 pi, and if we divide throughout by 2, we have pi over 2, here we have x over 2, and here we have pi, right? So now from this inequality we see that x over 2, it belongs to the second quadrant, right? It belongs to the second quadrant, and from the sign convention of trigonometric functions, we know that when the angle belongs to the second quadrant, then cos function, here cos x by 2, is negative, right? So mod of cos x over 2 is negative cos x over 2 when x over 2, it lies between pi by 2 and pi, or in other words we can say that x lies between pi and 2 pi, right? So now viewers, once we have decided the sign of mod of cos x over 2 in these two intervals, we can write I as 0 to pi, and mod of cos x over 2 is positive here, and then we have the second integral, that is from pi to 2 pi, and here we have negative cos x over 2 dx, right? So now we have two simple integrals and we can solve them, and we know that the integral of cosine x over 2 is 2 sine x over 2, and the limits of integration are from 0 to pi, and here we have minus integral of cos x over 2 is 2 times sine x over 2, and the limits of integration are from pi to 2 pi, right? So now we'll substitute the limits. So we have 2 sine pi over 2 minus, here we have 0, x is equal to 0 here, so we have 0, sine 0 is 0, and here we have 2 sine x, for x we have 2 pi, so here we have simply pi and minus 2 sine pi over 2, right? And this sine pi by 2 is 1, so we have 2 times 1 is 2, and here 0, and here we have 0 because sine pi is 0 and sine pi by 2 is 1, so here we have simply 2 times 1, that is 2, and this is 2 plus 2, that is 4, right? So the value of this integral is equal to 4, right?